This video involves what is called compound probability. Now, what compound probability is, is an event that is made up of more than one event, so two or more events. Okay? Our objectives today is we have to define or understand whether the events are independent of each other or whether whether the events depend on each other or not. So we're going to talk about independent and dependent events. Okay. Um, and then we're going to also work on finding what's called compound probability. All right. Basically, you want to think of that as ands, ors, or overlaps. All right. Okay. So, how do we differentiate between independent and dependent? It's independent if the occurrence of the event does not affect how other events occur. Dependent means the occurrence of an event does affect how the other events occur. Here's an easy way to think about it. Think about if I'm holding a deck of cards. There's 52 cards in a deck. Okay. If I take a card out and I say, what's the probability that you get a six? Let's say that. Well, that would be 4 out of 52. Okay. If I have you then select a card and then look at that card and then put it back in and say, what's the probability you pull a 6 out the second time? Well, that probability stays the same. It's still going to be 4 out of 52. But what if I asked you to take a card and then take a second card? All right. Well, now you're talking about what are called dependent events. Because instead of having 52 cards in that deck, if you don't put the card back in, now you only have 51 cards in the deck. All right. So whenever you're asked to calculate the probability of a compound event, the first thing you have to decide on is, are these events independent or dependent? All right. So let's focus on that first. Are the outcomes of what we're doing here independent or dependent? It says choose a number tile from 12 tiles. There's one event. Then spin a spinner. So think of one of those spinners, where you put it on a table and you kind of spin it and it ends up in a particular region. Okay. Do those events tie into one another at all? No. So these two events, would be independent. All right. Now, how about B here? It says pick one card from a set of 15 sequentially numbered cards. Then, without replacing the card, pick another card. So you pick a card, which means there's no longer 15 in the deck. And then take another card. Well, there was only 14 cards, so the probability is going to change. These events are dependent. The outcome of the first has an impact on the outcome of the second. All right. So how about this next one? You roll a number cube and you flip a coin. They're independent. They don't affect one another at all. Okay. The first kind of probability that we want to talk about is for independent events. So these, remember, are events that one does not impact the other. All right. We have this formula that says the probability of A and B. And the key word here is and. To find that probability, you multiply the probabilities together of each of the events independently. All right? Here's what I want you to take away. And means multiply. And means multiply. All right, so let's take a look here. I got a desk drawer with 5 red pens, 6 blue pens, and 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper from the drawer without looking, notice there was a key word here. A pen and a paper clip. What is the probability that you select a blue pen and a white paper clip? So they want me to find the probability of blue pen and, there's that key word again, and, there it is, white, let's call it a white clip, white paper clip. All right. Because this is an and, I'm going to take each of the events and figure out their probability. So let's do the blue pen. Success would be 6 over total. Let's see, 5, 6, and 3, so that would be 14. And means multiply. White paper clip, so what's success there? We've got 16 white paper clips, and we have a total of 40 paper clips altogether. There's our two probabilities. Now, I'm going to simplify this a little bit. I know that 6 over 14 is really 3 over 7, and 16 over 40 is really 2 over 5. And if I multiply these two fractions, I get 6 out of 35. This is the probability. Now, again, remember, probability could be a fraction, success over total, but that fraction could be written as a decimal or as a percentage. Okay? Take a look at this next example. You roll a standard number cube and spin the spinner. All right? Boom. And I see it. What is the probability that you roll a number less than 3, and the spinner lands on a vowel? This is compound probability because we are doing two different events. They are tied together with an and because each of the events are independent. Okay? So the probability of less than a 3, so that would be 2 out of 6. 6 faces on the cube. 2 of the numbers are less than 3. And means multiply. A vowel on that, U is the only vowel, so that would be 1 out of 4, which would give me 2 out of 24, or a probability of 1/12. Okay, hopefully this is pretty easy. Next thing we want to define is this idea of something called mutually exclusive events. These are events that cannot occur at the same time. For example, I can't roll a number cube and get a 2 and a 4 at the same time. I could get a 2 or I could get a 4, but I can't get them both at the same time. This leads us to our second way of thinking about these. First of all, if they ask me for the probability of getting a 2 and a 4 at the same time, that probability, it can't do it. So the probability would be 0. But what if I said the probability of getting a 2 or a 4? Well, that leads us to the next one. All right. Remember we said and means multiply, or means add. And means multiply, or means add. We're doing two different events, probability of A and the probability of B. We're going to add those together. All right, so let's take a look at a problem like this. Now, even though they give us percentages here, I'm going to work with fractions. You don't have to, but you're going to see some problems involving fractions. All right, this one says, student athletes at a local high school may participate in one sport each season. During the fall season, 28 of the students play basketball, 28%, and 24% are on the swim team. What is the probability that a randomly selected student plays basketball, or, there's my key word, is on the swim team? Okay, so this is asking for the probability of basketball or being on the swim team. All right, or means add. So the probability of being on the basketball team here was 28 out of 100. The probability of being on the swim team was 24 out of 100, which would be 52 out of 100. I can add those numerators because my denominators were the same, and that's going to give me 52% chance that you're either playing basketball or on the swim team. All right. Now, if you notice, I could have just said 28 plus 24 is 52%. But again, remember, I said I want to show you as fractions how we would do this. Let's just do this one using the percentages. In the spring season, 15% of the athletes play baseball, 23% are on the track team. What's the probability that an athlete is either playing baseball or, there's our key word, on the track team? Probability, baseball, or track. All right, the probability of playing baseball is 15%. Or means add. Probability of track is 23%. If I add those together, the probability of being on the baseball team or the track team would be 38%. All right. So our last situation is what happens if things overlap? All right. Overlapping is very, very common. Okay. For example, if I roll a number cube, I'm kind of reading off of here, but if I roll a number cube, what's the probability of getting an even number and getting a multiple of 3? Well, 6 is a multiple of 3. I would count that in the probability of even, and I would count it again in the probability of a multiple of 3. I can't get I can't count it twice. So when do we have to worry about this overlap? First of all, we only have to worry about the overlap when it's an or. We don't have to worry about it for and scenarios, okay? But when it's an or, we're going to calculate the probability just like normal. Probability of A plus probability of B, but then we're going to take off the overlap. We're going to take off the A and B. I think you guys will pick up on this pretty quick on these couple examples that we're going to look at. So it says, what is the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? First off, there's my keyword or. There's my separator. So it's the probability of even or a multiple of 3. All right. So when it's an or, I want to think, is there an overlap? In the previous examples, there was no overlap. But how about this one? Well, on a number cube, how many numbers are even? That's going to be 3 out of 6. Or means add. How many multiples of 3 are on a number cube? Well, that would be the numbers 3 and 6. So there's 2 out of 6. But wait a minute. One of the numbers that we counted even and one of the multiples of 3 are in both of these probabilities. So we've got to take off that one that's in common. And that number is 6 is the one that was in common. 6 is even and 6 was a multiple of 3. So I take that one off and I end up with 4 out of 6, which reduces to 2/3. How about this scenario? Probability of rolling either an odd or, there's my keyword again, less than 4. All right? So it's the probability of odd or less than 4. All right. Before I even started this, I started thinking to myself, are there any odd numbers less than 4? Yes, there are. So I know there's going to be an overlap here. I'm going to start off by saying what's the probability of odd? 3 out of 6. Or means add. Probability of less than 4. Well, the numbers 1, 2, and 3, so there's 3 out of 6. Now, if I just stop right there, guys, look at this. This is saying that there's a 100% chance that it's either going to be odd or less than 4. What about the number 4 or the number 6 when I roll a number cube? If I say that the percent is 100% here, then I'm saying when I roll a number cube, I could never get a 4 or a 6. That doesn't make sense. So now we come into the overlap. I'm going to take the overlap off. In these odd numbers, I had 1, 3, and 5. In the less than 4, I had the numbers 1, 2, and 3. 1 and 3 got repeated. So I'm going to take off 2 out of the 6. This simplifies to 4 over 6 or 2 over 3. I hope this helps. Let me know if you guys have any questions. I'm happy to answer them for you. as best I can. Good luck.